All right. Hello, everybody, and welcome to the stream. My name is Nick Larson. It is June 12th, 2019, which is a really special day in my life because it's the day I got married. Today is my wedding anniversary. It's my ninth wedding anniversary. It's been a good go. All right. All right, it's about 12:05 in the afternoon, and today we're going to get back to what we were working on last week, which is collecting up the stories so that we can send them out. Start writing the blog post. Basically, want to go over all of the stuff that we did and then start collecting as best we can. All of the interesting things that we did on this project with the decision trees so that we can go ahead and start getting these blog posts written up. And I think now is probably a good time to pull up what it is that we were working on. So this was all happening on the blog. File, close all this, open recent. Okay. This was the draft. The draft is how we sped up decision tree processing. Okay. So it's broken into a few different sections. We start off with the introduction, which is like setting the goals for the project, listing the constraints, and then also making it very clear that we're trying to solve a very specific problem and not like a general purpose, like here's some decision trees and, make them fast. Doesn't matter, supporting any kind of arbitrary decision tree is not really the goal. And then after that, we talk about how we got it up and running, doing the really simple stuff like getting in the actual data to populate the trees, implementing a super naive way about going about it, and then verifying the correctness as a test. And then we are like, okay, let's take a look at some of the performance tuning. We start off with the trivial stuff, which is like shrinking the representation a little bit and then using really easy things. There's a lot of stuff that actually goes in here. Getting rid of link. There's a bunch of stuff that is going to go in here. This is only a few of the things. There was a lot of like really small stuff where it was like putting things in the right order. In fact, I should put that down. Lift this up here. Putting class fields in the best order. Stuff like this. And there's just like tons and tons and tons of these little things where it was like all of this little stuff, when you add it all together, actually cut off 50% of the time. It was a pretty big improvement overall. So I think all of that stuff is like the really entry level stuff that pretty much everybody ought to know. And so getting it all in one place makes for probably that by itself is a whole blog post. And then after this, we have finding out the really slow parts, the real, i.e. actual slow parts. Get some ideas, link where we think it's going, verify those ideas, do some profiling, simple, then move up to some more interesting profilers, then get into the profilers that are way too complicated for me to understand, and then go to the problems with all of these methods, which basically boils down to all they do is point you in the right direction. They don't actually tell you how to fix it. All right, the overall problem, which is what it was pointing us toward, was that there was a bunch of cache pressure. Then how did we decide it was cache pressure? That's a hard question to answer because we didn't actually know until later, funny enough. General approaches to fixing it: reduce the memory size, reduce the working set size, access data in predictable patterns. Those are all really critical. This is going to be good. Changes to the decision tree. Remember, we're just trying to solve our specific case. So here's a bunch of different approaches about how we change the decision tree. First, we reordered the features. That was our first attempt, and we actually spent a fair amount of time on that. We did some interesting work on it. Came up with a really good evaluation function. Turns out that wasn't the problem. Then, um, to parallel comparing sorting searching algorithms. To parallel comparing sorting searching algorithms. Introduce it, explain it, show it. Oh. Yeah, that's right. The Hugo Doll mentioned that in the way they teach things in academic land is basically by they teach sorting and searching, and what we want to do is we want to introduce it first, then we want to explain how it works, then we want to show it, then we would say how it would not work for this scenario. Okay, yeah, that makes sense. Okay, approach, evaluate all the samples for one tree at a time. That was a really big insight that led to what was our fastest approach for a long time. There was also a bug in this which showed us unquestionably that cache pressure was the entire problem. Not just optimize the thing the profiler said was slow. Oh yeah, and that was it also. That was another big insight. We had to take a big step back. Instead of looking at just the decision tree and just the part where the profiler was like, this is slow, you really have to consider the whole problem. And then you can understand why that is more of an issue. And it was... Why exactly was it? When we looked at the whole... when you look at just one decision tree at a time, the only thing you can do is optimize for this one set of input features and getting through all the trees, right? But if you look at the problem as we just need to get all of the trees done and all of the jobs done, then we can look at the problem totally differently. Okay, also the trees are quite heavy and churning through all that data is expensive, so we should reduce the churn. Yeah, that turned out to be the big insight. And guess what? It was way faster, but... wait. Guess what? It's also that we have a huge bug. Hey, what's up, Ganesh? Good to see you, man. Alright, there is always a branch at the end. Can we eliminate the extra branch? That's right. We wanted to take the last node of the tree and shove it up one level so that we could avoid that one extra branch. We did not actually implement that in a very standard way, but instead we went the compiling route. The compiling route, got rid of a lot of stuff, made it quite a bit faster. Okay, the bug that pretty clearly identified it as cache pressure, though, which really narrowed down the future ideas. Yeah, that was good. Approach better memory alignment for the trees. The trees were stored in objects that were spread out in memory. That's right. If we just shove them all into... Basically, this was going from... array of structs to struct of arrays. And that made a big difference, a really big difference. What if we could put them all close together? Just put it like that. Can also get rid of the indexes for the branches because they could eliminate and shrink. That's right, we did that as well. And this was another actual win. But it's funny because compiled trees was this approach where we took one tree and we evaluated all of the samples. And then this approach went back to the previous way where we had one sample and we evaluated it for all of the trees. And we still saw an improvement once this bug was fixed over compiled trees. All right, and then the very last approach that had a big significant improvement was to... Oh wait, no, we're not even there. Pre-compute as much as possible. Alright, this is something we've been thinking about all along. We tried repeatedly to pre-compute jobs, only because these are branches. Now you now have to create a set of trees for each job, which is an asinine amount of memory usage and is beyond our allowance. Instead, let's take another step back and look at the whole test compared to what's going to happen in production. There's only one user, so we can pre-compute the user and then run it for all jobs. And this, I think the title for this one is, I think the title here isn't really that good. The title causes, what was the real thing? So we did better memory alignment for the trees. And then we said, can we pre-compute? Is pre-computing possible? How about that? Is pre-computing possible? Computing possible. Okay. And then for this, this was another huge win. In fact, I don't even remember how much of a huge win it is, but I kind of want to take a look real fast. Now I'm streaming, so the numbers that are going to come out of this are not going to be super accurate. But we should be able to get some valuable numbers anyway. Oh, you know what, actually? Merge. There should just be... Nope. Hold on, I'm going to find this because I know we did this. Show 5 more. Okay, yeah, here is, and I can't copy that, copy image. All right, so here was the win. See if y'all can see this. The same at once is a version that takes advantage of, that's all the way back at the compiled trees level. It's not actually doing compiled, oh, it's this one actually. It's all the way back here. It took this approach and it really pushed it about as far as it could possibly go. And then we had this other idea where you pre-compute, when a user comes in, you rewrite all of the trees to eliminate all of the branches for the user only values, and then you leave all of the branches that are related to the job. And then you evaluate it for all jobs. And what we see is that the tree shrink method is actually pretty good. So where you have these standard deviations that are super high, you kind of have to discount these values a little bit. Even these 7 and these 4. These down here are actually pretty good. But these medians tend to be around the correct values. So what we saw is that we have 3 different versions of the decision trees. The first one is the standard one. That's the basic one. That's the one that uses 1,000 trees, a maximum depth of 5. Then we have this one called shallow trees, which is still 1,000 trees, but it has a maximum depth of 4 instead, which makes a pretty big difference in the amount of memory that you have to churn through. And then this last one is fewer trees, which is only 500 trees, but they go all the way 5 levels deep again. And what we see is that, you know, there's a lot of goodness in both of these methods. This is running for 5,000 jobs each. And this is also looking at a single user. It's looking at a single user and 5,000 jobs. So we have 2 super viable methods here that we've kind of come down to. We decided to go with the same at once version. Even though the tree shrink version is technically a little bit faster for the case that we really want to try, which is this one. And in this case, it still has some issues with it where it can be slow in specific cases. And it also has this really high standard deviation. It's just like, it requires just a little bit too much memory. to make effective use of some levels of cache. So in some instances, you end up like churning through a lot more data. But yeah, we have, like I said, we have two different versions that are going well. And that was where we got to down here, which is, okay, great. Now we have two things. And now I want to go back and take a look at some of the old videos and see if we can come up with, so culture of development, go to streams, go check out the streams. Then we moved on to prepping for production. Okay, let's do that. All right. Yeah. Getting ready for production. Okay, in this case, this stuff is okay. Look again at the problem one step back. See that our test does not match the production. We tried repeatedly. Yeah, another step back. All right, what's going to happen in production? Okay, so then this one is more like cleanup. Eliminating allocations. What else did we do in here? Let's just take a look at it. Okay. Eliminating all allocations, reducing memory churn as much as possible. Here, I just did these, so we can just copy and paste these. Okay, reducing memory churn, making a test that more closely mimics production. Wow, look at that, I already did both of these. And documentation. I'm not sure there's a lot of value. Hey, what's up, Ancient Coder? How's it going, man? I'm not entirely sure like this is going to be a particularly valuable other than eliminating allocations. I'm not sure this sort of stuff is going to be particularly useful in terms of what I'm hoping to get out of this series. So I think maybe we're just going to ignore it. I think maybe we're just going to ignore it. Well, there is the whole thing of making the decision which algorithm to choose. So over the last like month or so, I've been working on a project for work where the idea is we want to get rid of we want to make basically evaluating a random forest really, really fast. And we made a lot of progress on it, and it's all due this Friday. But as part of all of this, I want to write up all of the like process of like where we started, all the steps that we took along the way, what sorts of things did I learn, what sorts of things can other people learn, and then basically turn all of this into a giant blog post, or probably a series of blog posts, because it turned out to be quite a bit of notes. And that's kind of what the plan is. I think I just want to really sort of start fleshing out today some of these ideas a little bit more. Maybe start writing the introduction post. And I don't know, maybe we just have this be like a giant marathon document people can read as like a case study. You get a little more viewership if you post them individually, I guess. I don't know. Things that are too long, I just feel like people don't read. When it comes to blog posts and like, you know, you go and you're looking at news, you want something you can digest in just a couple of minutes. Maybe 5, maybe 10 minutes at a maximum. If it's going to be like an hour long, like no one's going to read it. And then also, I want to put a lot of visuals in this. Like a lot of a lot of graphs, a lot of just images showing the way that things are sort of like organized in my head and the way that what I'm seeing when I'm thinking about these sorts of things. That's sort of what I'm working on. I know it's super abstract, but that's it. All right, so let's try this. Let's try writing a little bit more for each of these. Okay, the goal for the whole project. Okay. Describe the project. Show where on the page it is being used. Describe what we currently have and why it's not keeping up with the times. What else is there about the project? So the thing that we had is falling apart. Okay. Okay, I think that's actually good enough there. And then here it's the requirements. We can get very specific with these. 5,000 jobs. Hey, happy Wednesday, Michael Jolly. Happy Wednesday, everybody. All right, 5,000 jobs. 99th percentile at like 85 milliseconds. Which means that 99% of all requests have to finish in 85 milliseconds. But that request time is actually the request time for the entire server side portion of this. So realistically, it's more like 50 milliseconds. 99th percentile. The other thing is must be single threaded. That was a big one. Must be single threaded. It's running on the same boxes as everything else. Literally everything. Everything else that is publicly web facing. Must be single threaded. And then a soft requirement on how much memory it can use. Just needs to be as little as possible. What are the other requirements? 5,000 jobs, had to get it done in about 50 milliseconds. Has to be single threaded. I think that was really like it. Okay. And then the other thing is we tried the most simple thing first. Keep the data, no, keep the model in the language it was developed in. That was atrocious. That was atrocious. I don't have a better way to say that. It was extraordinarily slow. But the good thing is we have graphs for it, so let's do that. Wait, no, show me more. I want to see more. I'm looking through my chat history is what I'm doing. For the graphs. Nope, not the one I wanted. XG Tune. Rock. Julia. Nope. Gonna have to go a little bit further back, I think. boost. Nope. More? Nope. I guess she didn't paste it in chat. So instead, let's go back to the date. So basically, our data scientist put together a test. You know what? I know where this is going to be. This is going to be in ML. And then it's going to be in Simple Talent Model. And it's going to be in Train Model. Call Targeting API. Oh, here it is, right here. Okay. Copy image. And then paste image. What do you mean it's not usable? It's totally usable. How is copy image not usable? There we go. Okay, so this is individual API calls, which is a single user to a single job. What you can see here is that 50%, if we like break this out, what we can see here is that 50% of the API calls took less than, if this is 0.125 seconds, and then we say this is about 1/5 of that, so 125 divided by 5, this is about 25 milliseconds for 50% of the user job combinations. Okay? We have to do 5,000 of these in a single request times 5,000. And then if we divide this by 1,000 to get the total number of seconds, it would take 125 seconds for a single request to be served if all 5,000 of them happen to fall in the lowest 50% of time that it takes to run them. And you can see that some of these took as much as like a half second over here. Like they got really, really bad. And so this was the goal. We had to speed this up. We had something that was taking 125 seconds. And we had, on an optimistic 125 seconds. And we had to speed it up so that all of this time got reduced down to about 50 milliseconds. So 125,000 milliseconds on average, down to about 50 milliseconds on average. And that's pretty much what we had to do. So what does that mean? 125, so times 1,000, divided by 50. Basically, we need a 2500x speed up. That's what we were trying to achieve here. It was atrocious. That's what I mean when I say it was atrocious. It was actually atrocious. Okay. Yeah, that's not going to work. Okay, so then we just do the simplest possible thing. Show a little bit of code. Show all the necessary code in a snippet. And then verifying correctness. I think probably all of this is a good first one, because after this, you know what, let's put this under here too. Okay. Switch to C# land. Didn't want to do it like that. Oh, come on. Okay. And then this right here becomes a pretty good blog post that says, okay, so we don't actually need to improve it by, 2500x. Really, it ends up being more like, I don't know, a lot less than that. I think it's like 400 milliseconds to do what we were trying to do. I think it was about 400 milliseconds. Okay. So what do we do now? That is a great first blog post. Do we go ahead and write that blog post? Because there's quite a bit of work to do here. I think so. Let's get something done, right? Let's get something live on the internet, and then let's come back and we'll figure out the rest, the more interesting stuff. All right, so let's get a new draft rolling. Hexo new draft. Actually, I forgot how to do the draft thing. Hexo draft. Writing. Copy this. Bring it over here so we can all see it. Pull this over here so my head's not in the way. Alright, so what we need is Hexo new layout title. Post is the default layout. Okay? But you can supply your own. You can change the default by editing default layout setting in config.yml. I'm not super interested in doing that. There are 3 default layouts: post, page, and draft. Hexo new draft. Oh. Newly created posts are saved in the source post folder. Okay, interesting. Hexo new photo. When creating post, you know what? I'm just gonna drag it to the drafts folder. That is my way of doing this. New post. Okay, and we're gonna call this how we sped up random forest processing. Part 1. Getting the lay of the land. I guess. I'm not good with titles. Okay. Don't care about that. Drag this to drafts. Yeah, I do want to move it there. Thanks. Okay, great. Actually, I don't. Now I don't know which one's which. Getting the lay of the land. Okay, put that in here. Okay. And then what we want to say is open it. Close this. Drag this over here. All right, now let's get this post started. All right. Decision trees. Decision trees are one of the biggest jokes in all of AI. And then let's go take a look. We want to go to unmasking AI if-then statements. Images. Scooby-Doo AI. I think I want Scooby-Doo. Scooby-Doo AI. Okay, great. How do we go get this? There's got to be another one that's like... If. Okay. Let's copy this, I guess. Save image as... let's go ahead and go to code, culture development, source, image, and for this one we want to put in Scooby-Doo AI. Okay, now we need to go get it from here. Okay. And then we want to say decision trees unmasked. And then this is how do we put images in here? How do we put images in here? How do you put images in here? There's one. Image. Okay. Image / Scooby-Doo AI .jpg small image source 9gag.com small. Okay. But it turns out they are quite powerful after all. Okay. Let's do the old Hexo server. Okay, now we ought to be able to go to localhost. 4,000? There we go. Blog, how we sped up random forest processing, getting the lay of the land. Wow, I haven't blogged in forever. Alright, decision trees are one of the biggest jokes in all of AI. I need to make that smaller, my lord. Maybe? Why is small not working? Why is small not working? Do I need to whitelist it? Hexo. You can close that. You can close that. Okay. I want to go to writing. I'm in writing. That's it. That's all I got. Front matter? Nope. Tag plugin data server generating. Permalink themes helpers. Crap. What I really want is Markdown processor. Sort of thought this would be easier. Configuration, commands, migration, asset folders, data files. Nope. Server, generating, deployment, permalinks, templates, partials, local variables, optimization, variables. Nope. Helpers. None of this is really that good and helpful. Oh, HTML tags. String manipulation, templates. List miscellaneous. This isn't helpful. That's my short answer. API, docs. API. Render. No. Rendering. Themes, plugins. I really don't know how to do this. Let's just go search. Hexo Markdown allowed tags. PBR headers H1 H6. Maybe I do H6. Block quote. Code. List. Ordered. Indented. Code block. Nested. Code blocks. Syntax highlighting. This is sort of where I'm at. Nope. Horizontal rules. Table, span elements. Yes. Tags. Reference. Emphasis. Code. Images. Strike through. Automatic links. Backslash escapes. Inline HTML. Here we go. Note that the Markdown formatting syntax is not processed within block level HTML tags. Markdown syntax is processed within span level tags. It doesn't tell me which ones are allowed and which ones are not allowed. For any markup that is not covered by Markdown syntax, you simply use the HTML itself. There's no need to preface it or delimit it to indicate that you're switching from Markdown to HTML. You just use tags. I mean, that appears to be false. Unless I'm missing something, that appears to be false. Because in my rendered version, it just came out as small. Um, I don't know what to say. H6? What if I just try like H6? Refresh? No. Okay, I don't know what to say. Probably want to put this outside of here. One, two, three, four, five, six. Let's try that. I mean, that's going to put a giant header around it. Like, that's not what I want. Yeah, actually, that's not too bad, huh? Okay, yeah, whatever. That's cool. Alright, but it turns out they are quite powerful after all, especially when you use a lot of them. Alright. I tend to get a little... What are we doing here? Bruce Wilkie Jr., welcome to the show. We're basically writing the first blog post in a series of blog posts about all of the work that we've been doing for the last month. So what we did is we have a model for a new ad selection algorithm, and what we're doing is we've done an incredible amount of work on it. We learned a ton of stuff in this process about how we took the model and it went from being extremely slow to being usably fast, right? Not super ridiculously fast, but usably fast. And there was so much learning along the way. And before like all of this stuff gets out of my head and I start working on other projects, I just want to write some of it down and get some blog posts out. So what we did is we wrote down all of these notes, like a shit ton of notes. What is that? 100 lines of notes? Not quite 100 lines. 90 lines of notes. And now what we're going to do is we're going to take these first two sections and we're going to turn them basically into an introductory blog post about like really setting the stage for how big of an improvement we have to make in all of this. And if you're interested, let me go ahead and actually just check this in. And you can actually go and check out the notes yourself. Great, go ahead and complain. Notes for blog posts on random forest. And you can find this on my GitHub. Bang GitHub. I really have to change the way that this works because it keeps putting out there the JS13 thing. Let me just fix that up. Stream elements. Oh man, don't put a pop-up in my face. I don't want to see a pop-up. Now, let's go to here. Chat stats, media requests, profile pages. I know somewhere in here is the thing that handles the like, oh, chat commands right there. Boom. All right, bang GitHub, edit. I want to edit this one. How can I edit it? There's not an edit button. Oh, there it is. Wow, it's hidden right off the edge of the page. All right, the main group. The main GitHub org used for work on this stream can be found at all right, there we go. Ask about the individual project you are interested in through chat, using chat. All right. Okay, let's try that one more time. Bang GitHub. There we go. Okay, is this a bot you built for Twitch, or are these commands a native feature? No, they're all provided through Stream Elements. At some point, I'm going to get around to actually getting a bot set up, but like, I don't even have icons yet. Like, I'm just a little slow on it. I've been working on projects, not working on the stream itself, and I really need to take some time and set aside and get that stuff done, but I just haven't done that yet. But yeah, it's a website called Stream Elements, and you can see that Stream Elements, you know, you just like specify the command and then the message that should come back when somebody actually uses that command. They do, but I don't use the packaged up one. Basically, the way that it works is you like connect Twitch, your Twitch account to Stream Elements, and then it just sort of inserts a bot into your chat automatically that handles a bunch of things like right out of the gate. Hey, what's up, Hugo Doll? No, it's all good. Focusing on one thing for too long is sort of a negative in my thoughts. The way that I go about things. So like having a little brain break makes it easier for me to keep moving. All right, it turns out they are quite powerful. I tend to get a little upset when I see that meme because the interesting part isn't really how they make the predictions. It's in how they are constructed, which is legitimate ML. In any case, let's take a brief look at how a random forest works. Well, a random forest focusing on chasing squirrels is never distracting. Yeah, we are working on the blog post that we outlined last week. I think the comment is that AI is not what people assume is AI. When people see a bunch of skip logic and if statements, it's not perceived as AI. Yeah, the definition of AI, so this is a fun conversation. So the definition of AI is interesting and changing. Largely, AI is considered to be like things that we haven't figured out how to solve yet. Yeah, that's fine that AI is a marketing term. I don't have any problems with that. Like the general idea is that the thing that is making the decision is a computer, right? How it goes about making those decisions is super, super interesting, even if it is just if-then statements. But yeah, I think machine learning is actually turning into more of a marketing term than AI. AI was like a marketing term back in the day that like was debunked for what they were trying to sell it as pretty quickly, which was general AI, which like we are so far from even today. But ML is one of these ones where it's like, oh yeah, the application learns how to perform best. the machine learning still requires user created models. Um, Not entirely sure I agree with that for everything. I mean, if you mean like somebody has to sit down and press a button and provide it input and whatnot, then yeah, I mean, you sort of have a case there. But if what you mean is that we have to have an idea about what the model looks like for it to actually perform well, I'm not entirely sure that all things fit into that category. There are definitely some robust learning algorithms. Google has one called AutoML. Oh, okay, yeah, the former for sure. I mean, yeah, there is not a general sentient AI out there that's just creating a bunch of algorithms to like solve individual problems. That just doesn't exist. All right, a random forest is basically a collection of decision trees that all vote on what they think the answer to a query will be. At the end, you just take the maximum voted category, and that's the solution. That's the prediction. In the case of a regression problem, such as we are going to have here, instead, the results of each tree are added up and then transformed into a prediction afterward, depending on the prediction type. All right. Once that occurs, it's possible that we are out of a job and we reach a utopia where we no longer need to work, which could also be a dystopia. I would definitely think that would be a dystopia. The reason I think that is like if you just go meet a bunch of people who have like retired, the like losing your goddamn mind rate of people who have retired is pretty high. It certainly happened to my dad when he retired. For the first like 3 years, he just did not know what to do. He lost an incredible amount of weight, started dealing with all kinds of health problems. Like he was just so used to going into work every single day and having his 2 days off that when he all of a sudden just didn't have a job anymore, he just didn't know how to deal with it. And that actually happens quite a bit, it turns out. As far as like us all being out of jobs because of I largely think that's way overblown. It hasn't happened yet, and for it to happen, like we would have to build things that replace human thinking. Like we would have to understand the brain so much that we could produce something that could perform better than the human brain in order to solve the kinds of problems that we are all solving. And then second, if we could do that, there's a possibility that we could also modify our own brains to be able to do more. And then lastly, like to like just pile on to this whole idea is instead of creating things to replace ourselves, it's much more likely that you would create something to be your equal, right? Like, we could just get a lot more done if we had a lot more people. But feeding people is hard and all of that kind of stuff. But if we just had a bunch more things that could solve the kinds of brain problems or the kinds of problems that we solve with our brains, then all of a sudden we'd be able to solve a lot more problems. And it wouldn't mean that there are less problems. It would almost certainly mean that there are more problems. So I don't see like humans going out of work. I also don't see the robots being endless working bots, right? I see them doing the same sorts of things. They're still going to work. They're still going to rest. They're still going to, participate in uh, technologies and whatnot, just like everybody else. Hey, Codebase Alpha, thank you so much for the raid, man. I really appreciate that, and welcome everybody. So glad to see y'all. And what we're doing today over here is just writing up some blog posts. But hope you had a great stream. What are you working on? Link Slumps, thank you so much for the follow. I really appreciate that. What's up? And Surly Dev, hey, what's up? All right, let's go back a few here. If you have, which could also be a dystopia, if you have no drive or goals or things they need to accomplish, you will deteriorate. Probably true. I think that's because people don't plan past retirement. They figure, all right, no more work. Then they don't know how to use their time. Yes, that would be ideal. If ML technology could, so the ideal thing, all right, well, let me just go over these one by one. So the whole not planning for retirement, in the case of my dad, it just so happened that he was, in a sense, forced into retirement, not in a negative way, in a like they weren't going to continue giving him raises. He was a police officer. They weren't going to continue giving him raises, but they had to raise the amount of money that they were paying like police officers because they weren't able to recruit enough. And so what they did was they took all of the people who had been there for like, I don't know, 25 years, who were like right at max pension, who were right about to be at max pension. I think he was there for 23 years. And what he did was said, okay, we're going to basically just pay y'all out and we're going to give you a nice bonus. And so like he had expected to be retiring in like 2 years, and then literally like 3 weeks before my parents, I'm sorry, 3 weeks before my wedding, which today, funny enough, is my 9th wedding anniversary. Absolutely today. But yeah, like 3 weeks before my wedding, he just didn't have a job anymore. And so like the whole planning part of it was just like it got really, really, really like sped up. Thank you everybody for the congrats on my anniversary. I have no idea if we're doing anything this evening. I don't think we are because the babysitters all bailed on us. But we'll find some time to get something done this weekend. But yeah, so that was like the whole. I'm not entirely sure. Like I don't know enough people who have retired to know like what the primary reason is that they go crazy. What ended up working for my dad to kind of get over it was like getting a pseudo job, like finding something that he could go and do all day, every day, and it made him a lot better. So the ideal part of like, I'm not sure what your comment was, Bruce Wilkie Jr. As far as what ideal related to there, because I kind of covered a lot. But if you wanna fill me in, I'll be happy to address it. If ML technology could compensate the lack of IQ and a large set, the lack of IQ, a large set of the population suffers from, we could achieve much more together. That one's a little more complicated. I'm not sure. I'm not sure if lack of IQ is as much of a factor as like just the general well-being of individuals in different places. Like opportunity is definitely not equally spread. So if opportunity was more equally spread, then perhaps that would be less of an issue, or it would seem like less of an issue. Yeah, I don't know. That one's hard for me to address without getting into like too much. Mom asked today when I was going to get hired as a data analyst. LOL, this should help. Well, hopefully. That's what we're here for. This is all a learning experience. So, yeah. I'm pretty sure I will be able to fill my retirement with stuff. Wow, that's awesome. How close are you? Red circled. My parents just retired. Yeah. Happy anniversary. Congrats. Babysitters, we need a kid watching API. Maybe? That's a great question. Okay, so one of the questions we got asked at school, Chuck E. Cheese is always there to entertain the kids. They're not quite that old. One's 3 and one's 5. But it's funny. So the babysitters having a kid watching AI, that's a really interesting topic. We were asked this question in my knowledge-based AI class in school about a year and a half ago, where we had to basically analyze whether or not you would be willing to vote for an AI for president, right? Now, there is a lot going on in that sentence, and your gut reaction is probably, oh God, no. Oh God, no. Right? But when you start thinking about it, instead of just saying, oh God, no, immediately flip your thinking to saying, what would have to happen for your answer to be yes? And then it turns out that, well, a lot of those things might not be too far off. Um, then we switch topics a little bit. So, okay, we have an AI that's basically in charge of a large number of people. That's one crazy thing. But then you already have an artificial intelligence. That is a good point, Surly Dev. it's a it's a little untamed. um, the the second part of it though is what if we reduce the scope of this AI now? Would you trust your life in the hands of an AI, right? And then the idea becomes, would you let an AI drive you around? Like, would you ride in a self-driving car and just be like totally cool with it? There's a lot less going on there as far as like how much responsibility this thing has, but it still comes down to a really big trust issue, which is, would you get entirely under the control of an AI? Like, is that something you could submit yourself to? And like for me, the answer for that one is like a very obvious yes. I think self-driving cars are absolutely unquestionably going to be the future, and they're going to make like tons of things in day-to-day life enormously better. So I really look forward to it, and we could get into this conversation. Is that what y'all want to do? I'm totally happy to. AIC. Yeah, same age as my kids. Chuck E. Cheese. Link slumps. AI seems too dumb to do it. Bruce Wilkie Jr. AI for president is fine. AI kids watching is no. I'd love to hear that argument. You already have an artificial AI for president. That is very largely true. Start at the state level first. I'd settle for anything with an I and power. Are you saying an AI isn't already in charge of it all? Nobody could be that naturally well like him. uh, that's me not getting a visa if they do ask for social media nicks in future. Yeah, whatever. Definitely would not allow an AI to babysit. Someone told me that trucking will be the first to be automated. Yeah, I would also be happy with that. I would definitely be happy with that. Lorry drivers will be the first job role to be lost to AI, I think. Right, in like a sense though, right? They're not going to like become less useful people. Maybe some of them where their only like skill in life is driving, but I feel like responsibility of companies who are replacing jobs, one of the responsibilities should not just be to replace the job and let these people fall off. It should also be to like plan out where they go, right? Like get them some training for something else. You've got more money coming in because you're paying a lot less for this thing now. Why don't you be responsible and say like, that person was good enough to do this job. Don't throw them to the wayside and say, okay, now you're responsible for going to like figure out your own next thing. You should also, as a company who is replacing those jobs, be responsible for getting them trained up to do something else that could additionally benefit your company or another company. Like that's one way I would definitely see this going. In a very capitalist sense, that probably won't ever happen. But like from a responsibility sense, I feel like that is the responsible way to go about it, or a much more responsible way to go about it. Like if you hired this person because they have some value in what they can accomplish, like maybe they can accomplish something else, and you should worry about those sorts of things as well, not just replacing them. Trucking is the most common jobs in the US. Oh, wait, no, I got to go back further. All right, that's a very big bubble to be in, though. For example, is that a single ideal self-driving car with AI with the world as it is today, or are there environmental factors and changes? I believe, I mean, yes, there are absolutely, but I'm not sure. I'm not sure the two things overlap. Like they're not entirely orthogonal concerns, but they're very close to perpendicular. Trucking is also the most common job in the U.S. Has anyone seen Person of Interest? No, I have not, but if anybody else has, that's cool. Uh, Ancient Coder already implemented in Norway self-driving lorries. That sounds cool. That sounds awesome. AI should be about upskilling people. 100% absolutely believe in that. And a lot of the stuff that I hope to accomplish like later in my life is exactly that. Even where I work today, I have the ability to direct people to questions more based on their thing, which is a form of AI, right? Showing them the questions that are most likely to answer their their problems. And it's not limited to like Google, right? Let me not get into this. Let me catch up with the chat here. Well, if you're not paying less for a thing, I could totally see them transitioning to a role similar to pilot. The plane pretty much flies itself. Yes, it does, absolutely. And you still have to have two pilots, but the pilot oversees and takes over if something goes wrong. Automate the mundane and repetitive, upskill. You know, trains are the same way. Trains are almost entirely self-driven. In fact, they had this problem when they got to the point of having self-driving trains where the conductors, and they still had to have a conductor in these things, would just fall asleep all the time. And so the conductor's primary job while driving a train, many kinds of trains, like long distance haul trains, is to stay awake and press a button every time a buzzer goes off, right? And a buzzer goes off, like, say, once a minute, once every other minute, kind of randomized a little bit. It's not a consistent spread in time. If something goes wrong, they still have the ability to take over and pull all the the whatevers. But just staying awake is one of their things. Automate the mundane, repetitive. This is Surly Dev. Upskill the workers to use their brains more. 100% agree. Bruce Wilkie Jr. The entire point of adopting automated vehicles is to save money, so giving all the employees job ruins the profit incentives. I'm not entirely sure I agree with that. Like, regulate it if you have to. I mean, that's just what it comes down to. Like, you can't automate everything, and if you can, then we're teaching people the wrong stuff. We're already using routing of these trucks based on logic modeled after ants. That's cool. I'd be interested to see where that is. That's Johan B. Ancient Coder, Surly Dev. Yeah. Bruce Wilkie Jr. As human beings running the companies, I can understand them wanting to help, but depending on the size of the company and its money. Ancient Coder, the Michael Jolly. There are times when human intervention becomes necessary. That's true. That's absolutely true. Surly Dev. So true, the Michael Jolly. The majority of driving done by AI, lorries all creating a train to slipstream and save fuel space. Oh, save. I think that's save fuel and space on the drivers just monitoring until time to leave and drive on local roads. Right. Yeah, even if all we had was self-driving cars like on the highways, that would still be a huge improvement in my eyes. It would mean like long trips. Like if I want to go on vacation, instead of me being all jacked up on 5 hour energies so that I can like pay attention to the road and still dealing with all of the crazy kids in the back, if there was something that could just focus on like the road and handling the driving, it'd be cool if I could just sit there and like watch a movie with my kids for like an hour and a half, and then boom, the trip seems a lot shorter. We have a lot. I'm in a lot better spirits when I get there because I'm not all wired. Like all things about self-driving cars, I'm just like all over it. I just love the idea. Person of Interest is about an AI that monitors people to prevent crimes. That is a negative use of AI. It's pretty good, quite scary in parts. I can imagine it's quite scary. I don't think surveillance is an ethical use of AI. Just period. Trains aren't yet self-driven in the Netherlands, with possibly with the possible with the possible exception of having a babysitter AI. I mean, kids have to be watched to some degree, and especially in places where you have way too many kids, like daycares and whatnot, like having some AI in there to point out when things are going wrong is not a bad idea. Train companies are trying to get rid of conductors. George Jetson type work. The DLR in London has no drivers. I don't know what Docklands Light Railway. It's quite funky. Yeah, there are a lot of even like the trains at most airports here in the U.S. don't have conductors. They're just like automatically they drive to the next stop, and then they people get on, people get off, and then they drive to the next stop, and they're on a closed loop. They're not like on roads with other trains or anything like that. So I think maybe those small use cases are a good place to start. Trains aren't self-driven in the U.S. either. Maybe not all of them. There are central dispatchers that actually went down a few months ago in Texas, and that halted the train traffic in Seattle. Crazy. A paper, there have been a few around this ant thing. Oh man, that's cool. Let's go check that out. Solving the... oh, gotta get out of here. Put it in here. Solving the feeder vehicle routing problem using ant colony optimization. That's kind of cool. To check that out. Wow, that's a lot. Holy crap, that's a lot. Goodness me. Okay, look, that's if-then statements. This is a really poorly designed website. There's like no section headers at all. It's just a giant like 5.4. Like this should be bold and large so that I could easily scan it. Okay, 6 conclusion is not that bad. So that's another thing. When you're reading papers, like I don't ever read the entire thing at the beginning. First thing I read is the abstract to see if I'm even interested in continuing. Second thing I read is like the first 2 paragraphs of the introduction. After that, I'm just scanning to look at the titles of the sections so I can kind of get an idea. I'm also looking at the plots to see if any stick out as obviously important. And then usually I'll come all the way down to the bottom, again looking at the plots to see if anything stands out. These giant tables of data, I'm not going to look at that. I'm not going to take the time to understand what all of that is. I want to see it in a graphical representation. And then I come all the way down to the conclusion and I read the conclusion. If I'm still interested at that point, then I will go back and read everything again. And I will not pay attention to the math. I will just try to understand the intuition. And then the third time through, if I'm still interested, even after all of that, then I might go back and try to understand how it all works. Let's see here. We should do a podcast, man. Would be a great topic. These are research papers. Most are like this. I mean, yeah, I know. I've read quite a few research papers. Grep through those all day long. What do you do, Bruce Wilkie? What do you do, Johan B. Also? Just curious. All right. DevOps. Okay, that's cool. Oh. All right. I call myself a cloud monkey. All right, fair enough. I call myself a data engineer. Nick Larson's over here solving AI, and I'm like, can I make this LED blink? Man, I like making LEDs blink too. I just haven't taken the time to do that yet. I have a whole box right here full of LEDs that need to blink. In fact, show and tell. All right. see. There we go. I've had this accelerometer that I want to use for... Oh, look at that. It's green, so you can see right through it. But yeah, I've had this accelerometer that I've wanted to use for a while. Here is one of my Raspberry Pi Zeros. And, you know, the like little helper kits and all of this kind of stuff. What I want to build with all of this stuff is I've been really getting into running. And the like Fitbit that I have that I normally keep on my arm, it's great because it like measures your heartbeat and it measures, you know, the via accelerometer, how far you've run, how many steps you've taken, all of that kind of stuff. But what I really want to do is I want to make something that can like live stream what's happening to my body while I'm running. Right? This would be like video built into some sort of headset that had some sort of access to be able to stream. There would also be like graphical displays, maybe over, you know, on this side of the screen or something like that. So you'd be able to see sort of where I'm looking, where I'm running. But then there's like graphics that show my heart rate and like maybe which one of my legs is forward at any given time, where my arms are, stuff like this as like a very, you know, look at what I'm doing. You'd still be able to have chat, so you'd be able to talk to me while I'm running. And maybe some sort of voice recognition that would turn whatever I'm... Well, maybe if you can just hear what I'm saying, although I don't really talk that much when I'm running. But I want to do all of this kind of stuff because I've been trying to run longer and longer, and I want to collect data that I can use to use machine learning to see if I can improve my own running, right? And I haven't figured out how to get enough data from this thing to actually be able to do any kind of learning. All it does is give you a bunch of like stats, right? Got all these plans, just don't have any time. I can, but it involves putting an LED bulb into a socket, then flipping the switch on and off. I did yesterday. There's no guarantee for the future, though. Another thing that Michael Jolly is... You know what? Shout out to Michael Jolly, actually. Shout out the... Michael Jolly. Big shout out to the Michael Jolly because I am super interested in all of the like planter stuff that you've been doing, and I just haven't had the time to watch all of it. But like I literally have it saved in my like go back and watch this list, and I'm hoping I can get to it before Twitch kicks the video off of the whatever. So we have a garden out on the deck, and we've got maybe probably 40 or 50 plants up there. And we started getting some fruit off of it. Some like we got cucumbers and squash and zucchinis and like all kinds of crazy stuff growing up there. And of course tons of tomatoes. But like one of the problems that we've had is keeping it watered, and like I absolutely want to use some of the stuff that you've been... Oh, you have it on YouTube also. That's great. I didn't know that. I don't ever know where to go find other people's stuff. Who is it that's working? Is it Dev Chatter that's working on the tool to like go find the streams of people? I wonder if we could convince him to also like put a list of the recent work or like links to, you know, the recent videos somewhere that you can watch them on whatever search system it is that he's building. But yeah, if you want to link to that, that's totally cool. But yeah, I'm super interested in it because one of the biggest problems that we've had is like literally by the end of the day when I come up from work and I go up there, all of the leaves are like super droopy and they're like, oh, I don't want to do this. But it rained for like the last 3 days and they've just been like, hallelujah, right? I mean, these plants have just been going completely bananas and they've just been loving it. And I'm like, okay, I know I need to water them more. I absolutely know I need to water them more. But the issue is that, you know, I only have one time a day right now when I can go do it. And ever since the rain has started, they have been producing the most insane fruit, right? We got this one zucchini. I'm not even kidding you. It looks like a baseball bat. The thing is like this. I mean, this is my head. It's like literally like this big and like that fat. I mean, it's huge. It's just unbelievably big. And I'm like, I want more of these. I eat zucchinis all the time, and that's one zucchini was like two freaking meals, you know. And I'm like, man, I want this stuff. The Michael Jolly's YouTube link. Thank you for posting that, Surly Dev. I really appreciate that. Yes. Okay. Subscribe. Perfect. I will start getting notifications when your videos come out. That's awesome. Anyway, all right. That was good. I could talk about this stuff all day, man. I love this. Here's a lot of Twitch developers. Right. The also cataloged. Oh, here you go. You got a website too. Bald Bearded Builder. Nice. This website uses cookies. What for, man? What you need cookies for? On a blog. My trust level has just gone down. I actually don't think it does. Mm-hmm. That's what they all say. Mm-hmm. Needs cookies for the machines to monitor us, man. Oh, wait, yeah, it does for Google Analytics. Oh, yeah. That's right. Does that count? I guess it does. That's GDPR? Does that count for GDPR if you use Google Analytics? Oh, only if you're collecting personally identifiable. Okay, so only if my organization is collecting the information directly, do I need to have that? Or is it if any third party plugin that I have on my website is collecting anything? Okay, so then yes, if you have Google Analytics, then you have to have that warning on there because they are absolutely collecting your IP address. If that can be linked to you as a person. Right. So the second thing there then is, does your website not hit Google Analytics until I press the got it button? Or are you still breaking the rules? I'm totally breaking the rules. Yeah, that's fair. I think everybody is still breaking the rules. I know there's one on Stack Overflow. I have no idea what it actually changes. Right down here. By using our site, you acknowledge that you have done this. You know what? Let's just see what it's doing. How do I go to the... isn't there a way to see what's happening? Right? Actually, I can already tell you. There's a prov cookie on it already. And you didn't click this. So, yeah, you've been cookied. And I have collected, due to this cookie, your IP address. So, yeah. Great. Guess I shouldn't have done that on stream. Well, whatever. Only if users from the EU visit you. Well, no, it's not just only if users from the EU visit you. It's if anybody who visits the EU visits you as well. The message says that you agree just by using the sign. Network tab. Network tab. Right. Yeah. I just went through a GDPR training and it was like the most high level thing ever. All it was like is basically you have to get some sort of like active consent. You can't have passive you're using this site consent anymore. Was like the main thing. The thing that gets me the most though is it was literally one of the stipulations was if somebody requests to have their information deleted, you have to delete their information. But additionally, you have to record that you deleted their information. So how do you do that? Using the sign equals reading the sign, which is like saying by reading this message, you agree to give me $1,000. Right, yeah, that sort of thing is like explicitly not allowed by GDPR. You have to give active consent. Reading the sign is not enough. Like you have to click. And that's why if we like reload, no, I clicked away. Damn it. I guess I could visit literally any site and that pop-up will come up. Let's go to, I don't know, give me another site. Uh, Here's one. All right, so this pops up. Reading this is not. You have to click got it. You can't just like close this link. Right? That doesn't count as active. JetBrains have copy link address. Let's check this one out then. Oh, cookies and IP addresses allow us to deliver and improve our web content. JetBrains may use cookies and my IP address to collect individual statistics. Yes, I agree. No thanks. Oh, that is cool. I can revoke my consent at any time by visiting the opt-out page. I like that they're upfront about that. That was another one of the requirements, right? They have to be able to opt out very easily. It should not be hidden. I wonder if they broke the rules. Ooh, no cookies. Look at that. They are not breaking the rules. Nope, just kidding. They broke the rules. Oh well. Fun fact, the GDPR document mentions the warn cookie only once. The word cookie. Oh, that is interesting. All right. I am going to get back to actually writing a little bit. Oh, look, that's responsive. Oh, that's cool. Man, JetBrains does have cool stuff. I wonder if I can get them all connected. No, of course not. That would have been way too cool. Can somebody write them and ask them if we can turn this into a game where I actually can connect all of them? Does anybody here work at JetBrains? PII. A lot of companies in the UK emailed people to say, we have your details under GDPR. We have to ask for your permission to keep it for reasons, which was a breach of the data protection laws that preceded GDPR. Can you update your game in Twitch to jetbrains.com? Can you update your... Oh, doubtful. Category. Jet brain, nope. Jet ball, jet bros, jet boat, Zebo, jet board. There's some interesting J games. Science and technology. I got some of those emails from a bunch of recruiters. I'm going to guess that's recruiters? Recruiters? It's not a word I've heard of. Oh, wait. No, I want that one. No, reopen the tab. Oh, you can't remember it. Okay. Nope. 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 It's not this. It's a blog. Yep. 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 That's all right. Everybody's spelling is horrible. Okay. It turns out quite powerful after all. Let's see. All right, a random forest is, I'm not going to say basically, I'm going to say a collection of decision trees that all vote on what they think the answer to the query will be. At the end, you combine, okay, we're just going to ignore. In the case of a regression problem, such as we're going to have here, the results of each tree are added up and then transformed into a prediction. That's good enough. All right, that's it for a random forest. The actual, all right. You know what, let's not start with decision trees. Let's start with the problem. Describe the project. Okay, let's start with the project. All right. I work on the team at stackoverflow.com that deals with the selection of jobs in sidebar ads. Let's go open those up. Pi.hole. Turn this off. Disable. Custom time. Hot minute. Okay, let's take a screenshot here. Stack Overflow. Let's go click on a job. I want something a little more robust. Give me a 4 high. Come on, give me a 4 high. No, I said. I wish I could force this to give me a 4 high. But it's not. It's just giving me 2 highs. Man, IBM just lost a lot of impressions right there. Okay, we're getting closer. Nope. Geez, IBM must be our only active. Seriously? Just give me one time. How many times are you going to make me refresh this page? A lot, apparently. How's IBM hiring so much with the folks they're laying off? Transfer your big data up to 3 times faster. I mean, this is not a job ad right here per se. This is a, like, they want to sell stuff. I don't know, when it comes to IBM, I feel like all big companies are constantly laying people off and constantly hiring tons of people, right? What they're doing is they're ending projects, and if you only worked on that project and that project ends, your like institutional knowledge has just dropped a very significant amount, and so keeping you around isn't particularly helpful for them. Yeah, it is. I'm refreshing over and over because there is a way. There are some times it shows up and you get 4 job listings at once. And so I'm trying to force one of those to happen. It just doesn't seem to want to work with me here. It's like really fighting me on this. I think I'm just going to have to... Oh, look, I got one. That's it. You do it enough times, you finally get one. All right, this is what I was looking for. Okay. So I want to copy all of this. And then I want to save this. Wait, no, I want to draw on this. This. And this. And this. And this. Okay, now I want to save it. And we're going to put that in here. And here. And here. And we're going to call this SO job ads. Okay. Stack Overflow job ads. Image SO job ads.png. Let's see here. A lot of companies, GDPR. Can you update JetBrains and Twitch? I got one to work. I got one to my work email, and everyone's email address and the to field. Whoops. Instant data protection breach. I emailed them back to say, don't do this in the future. Random Forest reminds me of this question. If a tree falls in the forest and no one is around to hear it, does it make a sound? Who knows? Probably. How's IBM hiring? It's an ad proper. Okay. All right. These things. All right. The problem we have is that the model that guesses how likely the current visitor is to click on any given job needs to be updated from time to time, because to account for changing market conditions. Basically, new technologies come out all the time, and which kinds of technologies are being used on Stack Overflow changes over time. Okay. In this most recent round of updating the model, we decided to go outside of our typical process of using a logistic regression, and instead decided to try out numerous kinds of other models. Let's go ahead and pop a couple of things on there. Logistic regression. There we go. I should not call it. I should just call it what it is, lasso. Lasso regression. That's it. Okay. And instead decided to try out numerous other kinds of models. We had Hmm. At the end of the day, the best model turned out to be a random forest. The best model based on our selection criteria turned out to be a random forest. Yeah, the selection criteria was actually quite interesting there, but I don't really want to get into it because that is not what's important to this blog post. Random forest. We're just going to have Wikipedia links from the top of this thing all the way down to the bottom. A decision tree. Oh, wait. Okay. A random forest is basically a collection of decision trees that all combine to make a prediction. Alright. You may have heard of decision trees because they are the brunt of one of the biggest jokes in all of AI. Alright, but it turns out they are quite powerful after all, especially when you use a lot of them. I tend to get a little upset when I see that meme because the interesting part isn't really about how they make predictions, it's in how they're constructed, which is legitimate ML. Alright, a random forest. I don't need this anymore because I kind of already went over that. Alright. Training a random forest can be quite expensive, however, and we were not able to feed it all of our sample data. Instead, it was decided to try a similar model, XGBoost. Yet another link, here we come. XGBoost. XGBoost. Alright. This is calculated a totally different way using boosting. However, on the prediction side, it turns out to be almost exactly is trained in a totally different manner. Using boosting instead of bagging. However, the prediction side, it turns out to be almost exact. Well, I guess it still uses bagging, but it boosts the bags. We're just going to say using boosting. Okay. Turns out to be almost exactly the same as a random forest. Okay, let's get the boosting. Boosting. However, on the prediction side, it turns out to be almost exactly the same as a random forest. All right. So we have a new model. We hope it's going to be good. Now we need to run a test, which means we need to get this thing into an API that can be called from our production service. First thing we did, does that really describe the project? Well, no, we need to say, all right, so this is actually getting it up and running. This needs to be higher up. Okay, describe the current project, show where it is being used, did that. Describe what we currently have and why it's not keeping up with the times, did that. Requirements, no. So now we need to say, like, why. All right. All right. We need to test it. Describe what we currently have and why it's not working. Describe the project. All right, let's describe the project just a little bit better. The problem we have is that the model that guesses, okay. The goal of my team is to make the model that predicts the likelihood that a user will click on a given job if shown that job. Right. At any given time, there are 5,000 jobs or so on the job board that the current visitor can see. So this needs do I want to get into this at this point? Describe the project, show where on the page it's used. All right, so we calculate the expectation for each job, then we perform a weighted random selection over those values. All right, the problem we have is that the model that guesses how likely the current All right, the problem we have is that the model needs to be updated from time to time to account for changing market conditions. Basically, new technologies come out all the time, and which kinds of technologies are being used on Stack Overflow changes all the times, and which kinds of jobs are being listed changes all the time. All right. In the most recent round of updating the model, we decided to go outside of our typical process of using a lasso regression and instead decided to try out numerous kinds of other, is there a space here? Whoops. And decided to try out numerous other kinds of models. At the end of the day, the best model, based on our selection criteria, just one second, my wife is texting me like crazy. Okay. At the end of the day, the best model based on our selection criteria turned out to be a random forest. A random forest is basically a collection of decision trees that all combine to make a prediction. You may have heard of decision trees because they are the brunt of one of the biggest jokes in all of AI. Here's this image, hooray! But it turns out they are quite powerful after all, especially when you use a lot of them. I tend to get a lot of them together. I tend to get a little upset when I see that meme because the interesting part isn't really how they make the predictions, it's in how they are constructed, which is legitimate ML. And this is the joke right here of the whole blog post because the interesting part isn't really how they make predictions, but that's exactly what we're writing about. That's what this entire series is going to be about. That's the whole joke. At the end, we're going to come back and visit this, right? When you're telling a story, you want to like allude in some way, shape, or form right back to the beginning. So get right to the point pretty quickly. That was a very intentional sentence. All right, training a random forest can be quite expensive, however, and we were not able to feed it all of our sample data. Instead, we decided to try a similar model, XGBoost, which we could feed with much more data in the same amount of time. All right, this is trained in a totally different manner. That is using boosting. However, the prediction side of it turns out to be almost exactly the same as a random forest. So we have a new model. We hope it's going to be good. Now we need to run a test, which means we need to get this thing into an API that can be called from our production service, from our ad server. Okay. That's a good start, and I'm happy with that. And we now have a draft. And I need to go ahead and end this stream because it's been about 2 hours. I would like to thank everybody for coming to hang out. I would definitely like to thank everybody who participated in the conversation about AI earlier. That was a lot of fun, and I hope we can have more conversations like that in the future. Again, one more big shout out to the Michael Jolly for all the work that you're doing on Twitch, man. It's amazing. Thank you for stopping by today. Thanks for hanging out. And I'm sorry we were not able to switch our game over to jetbrains.com. I will reach out to Twitch and see if they can make that change for us. In the meantime, again, thank you everybody for coming. If you have any suggestions about who we can raid, please drop me a line really quickly because I'm going to go and look for that now. And then we're going to get people sent out here. I see. That might be a good topic for Monday or something. Imperial, Relevant Jesse, Instafluff. Who is Imperial? I don't know who Imperial is. I don't like earthquakes. If I could learn how to block that and all of the streams that are just growing marijuana, I'm just never gonna click on those. It's cool that you're doing your thing, but I'm just not gonna click on those. They really get in the way. There's so many of them. Who is Relevant Jesse? You know what? Relevant Jesse it is. Thank you for the suggestion, Surly Dev. We're going to go ahead and raid over there. Pick a live channel. It's not letting me. Okay. What's the problem? Oh, there we go. Raid. Okay, you have to choose the person. Used to be called Imperial Girl. Thanks for the stream. Have a good rest of your day. Thank you so much, Source Scoot. He's teaching C#. Might not be of interest to some of your viewers. It's okay. We're gonna head on over there. If it's not interesting, just find someone else. But in the meantime, again, thank you everybody for dropping by, and I will see y'all all tomorrow at 12 o'clock Eastern Standard Time, so about 2 hours earlier than it is right now. And we do this Monday. No, we do this on Wednesday, Thursday, and Friday at noon Eastern. Thanks again. See y'all soon.